Hello, I'm Mike Wheeler, and today we're going to talk about machinery safety and lockout tagout for week 7 of our safety and leadership course. Um, oh, Objectives: at the end of this lesson, you should be able to define what machine guarding is, explain the types of machine guarding that are out there, describe how machine guarding requirements are set, define lockout and tagout, explain the purpose of lockout and tagout, and explain the concept of zero energy state as related to the machine we were going to work around. So, machine guarding. Many machines require special guards to keep the operator safe, and OSHA has many rules and regulations related to machine guarding. Pretty much anytime you've got moving parts, guards are probably going to be necessary. Some of the hazards that we try to mitigate with machine guarding are pinch points, crushing hazards, shearing hazards, rotational hazards, power transmission, so that can be drive shafts, drive belts, or chains, and then stored energy, compressed springs, or stored electricity, usually in the form of capacitors. Uh, Generally, the distance the hazard is from the guard will determine the size of the opening. And this is set by the OSHA standard for machine guarding. It's part of the OSHA code. So the thought being, the um, the farther away an object is, the danger is from the guard surface, the bigger the opening can be. Because if what's going to hurt you is a foot away from where the guard is, um, an opening just barely big enough to get your finger in, that's way excessive because you don't have a foot long finger, hopefully. Um, so the farther something is away, the bigger the opening can be. The closer that hazard is to you, the smaller the opening is, so you can't get much more than a finger into it. And here's OSHA's rule: if the guard is within 2 inches of a moving part, the guard opening must be a maximum of 3/8. So it's pretty small when you're working with stuff that's close to you. And there are tools available to check guard openings for different distances from the hazard. There's a picture one on the next slide I'll show you. So what you need to remember, though, is manufacturers put guards on machines where they are needed in order to meet safety requirements, not just for OSHA, but other safety organizations around the world. Do not remove or modify guards. They are there for a reason. The number one thing OSHA inspectors do when they walk into a site is the first place they go are bench grinders, if there's any bench grinders, because the guards on bench grinders are never adjusted correctly. And here's a guard opening scale. As you can see, the farther away you get from, what the danger would be, the bigger the opening can be. And there's a short video you can watch. So machine maintenance and service. One of the biggest hazards associated with machinery is maintenance, cleaning, and repair work. In most cases, guards have to be removed in order to access the machine or access lube points or adjustment points or to replace stuff that breaks. Many serious injuries and fatalities in the workplace happen during cleaning and maintenance operations. Locally, there was a case where a woman was killed by being caught in a conveyor system. She was cleaning the machine while it was running. The guards were removed so they could clean it, and her hair got caught in the conveyor mechanism. It pulled her in the machine, and she was killed. And unfortunately, that's not a rare story. That is one of the most common causes of workplace fatalities when it comes to working with machinery is you get caught in it, and there's really like a lot of times those are going to be fatal injuries. There's another one, a pretty bad one. If you remind me, I'll tell you about in class. It's pretty bad. So part two. So in our own welding lab, we had an employee that lost a finger on our small plate shear. Our Chicago shear, it's actually taken a digit off of somebody, and it was during maintenance and repair work. The employee replaced the cutting blades on the shear and was setting the blade gap. You've got to set the space between the blades after you replace them. And you set that with feeler gauges. To do this, the guards that keep your hands out of the shear have to be removed so you can get the feeler gauges in there to do your measurements. So what happens, how this works is you've got to get the blades, when the machine is idle, the blades are separate, so you can't see what the gap is between them. You have to manually run the machine down and then turn the machine off while the blades are overlapped so you can set the gap between them. So the proper technique to do that is Um, everything should be locked out while you're working on the machine. When you're ready to cycle the machine, uh, everybody's working on it, takes their locks off the lockout. You cycle the machine with everybody at a safe place and turn it off when you need to, and then you get in there and do your, relock everything out, and then go get in there and do your adjustments. What happened, what our employee did was he didn't do any of that. He just, was going to fire the machine up, bring the blades down, standing there working on it. And the employee was unaware that his little finger on his right hand was underneath one of the hold down rams. And he turned to say something to a student, hit the button to cycle the machine, and the hold down ram came down and just absolutely pulverized his finger to the point where it ended up having to be amputated. So anytime guards are removed in order to do maintenance, cleaning, or repair, lockout tagout procedures must be followed and extra caution must be taken. It is truly what they call out of process work or out of sequence work, and that kind of work is inherently more dangerous because you don't have a set routine. You haven't done it 100 times before. It's something new. It's inherently more dangerous work. Machine controls. So machine controls are another way that machines can be designed to be safer to operate. Many machine controls are designed to keep your hands out of danger while you operate the machine. Some machines require both hands to activate. This makes it hard to put your hands in the machine while it's running. So like a press, for example, might have two buttons on the controller that you have to push them both for the machine to run. And that's to make sure that you don't have one hand on the controller and one hand in the machine. And some machines are made to be operated by two people. They have two sets of controls that are interlocked, meaning that it requires the operation of both controls to activate the machine. Again, is to make sure that one person doesn't operate the machine while the other one is in the machine. So lockout tagout. If you're in this industry for any length of time, you're going to get very familiar with lockout tagout. And understanding and adhering to its principles are absolutely critical to stay safe during machine and equipment maintenance and repair. So the two parts of that lockout. Lockout, you bring the machine to a zero energy state, and we'll talk about zero energy state in just a minute. And you lock out the energy source on a piece of equipment so it can't be energized while it's being serviced. And then how it works is people working on the equipment are issued individual locks and keys so that they lock out the piece of equipment. And if there's 10 people working on a conveyor, which is what I used to do many years ago, there'd be 10 locks on the power box that operated that machine. And it couldn't be operated until everybody showed up, everybody took their locks off. And again, this is to make sure that nobody fires up the machinery while somebody is still working on it. So tagout is used when you can't lock stuff out. A tag or a warning device is used to alert and warn others of a problem with machinery in unsafe condition. So tagout is inherently less safe than lockout since you have to be paying attention for them to work. You can ignore them or you can remove them, which is not ideal. Tags need to identify or should identify a source of potential danger, and they indicate the equipment is being worked on and may not be operated until the tag is removed. Most places I've worked at, if something is tagged out and you just disregard that and operate it anyway, you get fired on the spot. That's not something you can play with. And tags should describe the problem or issue with the machinery, and if possible, identify the person who tagged it out so that they can be contacted for more information. It's not real helpful when you hang a red tag on something, either blank or right doesn't work. That's not real helpful. The more information you can communicate, the easier it's going to be for the next person to figure out what's wrong with it. So zero energy state. So what is zero energy state? Broken up into two halves, and it's electrical and mechanical. And what we want by zero energy state is to create a situation where there is nothing in the machine, no energy in the machine that can harm us or injure us while we're working on it. So on the mechanical side, it's going to be pressurized fluid. If there's pressurized air, that needs to be normalized. If there's external power sources, they need to be shut off and locked out. Is that equipment supporting anything that when we shut the equipment down, will that stuff move? And then mechanical potential energy, so compressed springs or suspended parts, and then kinetic energy, which would be machines that run drop hammers or forming dies. And then on the energy side, introduction of no energy. So we lock out the power supply coming into the machine. Equipment or structure contains no source of energy. That could harm us or harm the machinery while working on a lot of the new electrical stuff. A little bit of static can do a lot of damage to the controllers in them. And then the big one for us is going to be no storage of energy, which, every time you open up a welder, there are giant capacitors inside, and those capacitors hold a lot of current. That's why we as welders should not be working on the insides of welders. That should be left to electricians who know how to discharge those capacitors safely, because they can light you up pretty good. So wrap up. Machine guarding must not be modified or removed. It's there for a reason. Some machines have operational controls designed to keep you safe. Don't attempt to bypass them. Maintenance and repair are often the most dangerous operations on a job site. Proper lockout tagout requires everyone involved to be trained on this procedure and to abide by the rules all the time. And zero energy state is much more than simply unplugging a machine or shutting down the motor of a piece of equipment. Going back to zero energy state, like you look in the lab next door where they're working on heavy equipment. If they're going to open up a hydraulic line, the bucket of a front end loader, if they open up a hydraulic line connected to that circuit, it's going to drop that bucket. So they'll put spacers in so that the spacers taking the weight of the bucket, and so that the hydraulic rams are under no tension. They're taking it to zero energy state. So it's actually really common. You just have to look for it. So anyway, here's your references, and I will talk to you guys later.